In today's lesson, we'll be looking at exercise 703, which is on linear modeling. Scientists and researchers observe patterns in nature and society and often use a mathematical formula to represent a real-life situation. So this is called algebraic modeling. And if the relationship uses the linear function y equals mx plus c, it's called linear modeling. Okay? So basically, you have learnt all about this formula in the last few lessons, where two important features that we've learnt about are the gradient and the y-intercept, and each of these actually means something to do with real life. And that's what it means by linear modeling. So we're trying to model something to do with a line in relation to life. Now, when you have these two letters, y and x, one of them is a dependent variable and one of them is the independent variable. Okay? The y here represents the dependent variable, whereas the x here represents the independent variable. So the dependent variable, which is y, always goes on the horizontal axis, and the x value, which is the independent variable, always goes on the horizontal axis. Okay? Now, when we look at a table as such, okay, usually when you graph them, or before you graph them, you have x on the first row, then y in the second row. But if you suddenly change this to a and b, then treat this always as x and treat this always as y. Okay, meaning the top term there is the independent variable, okay, whereas the bottom one is the dependent variable. And we're going to look at that later on as well. Now, the gradient is always measuring the steepness of a line. So it's how steep it is. So in terms of steepness, this will be more steep than this, and more steep than this, and more steep than this. This is the least steep line, okay, basically. All right, so it goes to more steep to least steep over here. Now, I've taught you how to find the gradient of a line before, but another way you can do this is just by looking at how much it goes up by from one x value to another x value, which is number 1. This is just the run. But when you look at the y values and how much it goes up by every single time, that's the positive 5, which is the rise. So if you think about it, if you have the rise of a run, that's going to be 5 over 1, which is 5. Okay? Right. The important thing that I want you to write down out of all this, okay, is that the y is dependent variable and x is the independent variable. Make sure you write that down. You don't really have to write this bit down because I think that's just enough of an explanation. But the next thing I want you to write down is this part. Okay? It's important that you know this. So the gradient and y-intercept. The gradient of a linear function is the rate of change of y. So it's how much y is changing in respect to x. Then, the higher the gradient, the steeper the line, and the faster y increases relative to x. Okay, make sure you write that down because in an exam we could ask you, what does a gradient mean? Okay, what does it mean? All right, so you have to say something increases when x increases. Okay, so say for example, the cost will increase as the number of burgers I buy increases. Okay. So there's an effect where one increases the other. Last dot point. The y-intercept is the value of y when x is 0. And we explored that previously as well. Okay, so make sure you write that whole box down. Okay, and I'm going to move on. Right, in example 6, Brett is organising a 21st birthday party. The total cost of the party will include $200 for hiring the hall, $120 for the music, and $14 per person for catering. The table below shows the total cost C for different numbers of guests and attending the party. So we can see that in the first row, which does usually represent our x value, and the second row is usually our y value, as the number of guests involved increases, the cost will be higher because you've got to cater for them. Now for part A, which variable N or SC is the dependent variable? The dependent variable is the y value, which is the party cost C. So I'm going to write party cost here. Now, you don't really have to write this bit down in your books. You just have to listen. All right. Question B. Find the gradient of the linear relationship between N and C. So remember, for this particular question, we just get a pair of x and y values, so these two. We get y2 minus y1, so that's 1,720 minus 1440 over x2 minus x1, which is 100 minus 80. Okay, and that calculates to give me 14, right? C, find the vertical intercept of this linear relationship. Right, so the vertical intercept is basically your C value. Okay, to actually find that, you have to generate your equation first. So usually you have, y equals mx plus c. Whoops, sorry. So usually it's y equals mx plus c. But instead of y, we've got capital C. Okay, right here. And we've got the m value, which is the number 14. And we've got the x value now, which is n. And then we have to basically plus the remaining c, which is our y-intercept. So there's big C and little c. Now, to actually find out what this c value is, you have to replace these two values by something. And these two values are basically a pair of values in the table. So I can make a substitution, and let's just say I substitute in 80 and 1,440. Okay, like that. So I'll replace C by 1,440. That's equal to 14 times 80 plus C. So 1,440 is 14 times 80, which is 1,120 plus little c. And once I subtract that 1,120 over, I get 320 as little c. Okay, and that's my vertical intercept. Then for part D, write the linear function for c in terms of n. So because I found c, I can actually put that back in here, so that the cost will now equal to 14 times the number of people, n, plus another $320. Okay? All right, then I have question E. So if this function was graphed, which variable would be shown on the horizontal axis? This will usually be the x-axis. Now the x-axis will be the number of guests, which is the first row. So you would say n, the number of guests. Okay, then for question F, what does the vertical intercept of this function represent? So, the vertical intercept here, right? If we have a look at the vertical intercept, which is 320, let's have a look back at the information here. What of this particular paragraph totals to become 320? Well, if you think about it, if there's 0 guests, right? Okay, if no one attends your party, and you replace 0 in, the cost would still be 320 because you actually hired the hall and $120 for music. Okay? So without catering for anybody, so no people coming, you already hire these two, so that costs money. So those 200 and 120 total to become 320. So this includes the hire of the hall, okay, hire of the hall, and also for the music. Okay? Alright. Question G. Find the cost of the party if there were 95 guests. So we've got our formula, which is 14n plus 320. We're trying to find out the costs. Okay? Cost meaning the letter C. And there are 95 guests which represent n. So we're going to replace n by 95, then plus 320. And in total, that basically gives us $1,650. Okay, I hope everyone understands that. Right. Because next we're going to look at example 7. Right. In example 7, A criminologist discovered that the number of crimes committed per month, C, in a big city decreased as the number of police officers, P, patrolling the city increased. After graphing her data on a number plane, she found that the linear relationship to be C is equal to minus 3P plus 3,250. What is the independent variable in this relationship? So the independent variable is always the X value, which is the first row. So that will be the number of police, so P. Okay, and why is because C, number of crimes, depends on the number of police. Okay? So what it's saying is the less police there are, the more crime there is. But the more police there are, the least crime there is. Right. So our formula says C is equal to negative 3P plus 3,250. You substitute in 50 as P in there. Okay, so on my calculator, if I do this, okay, I'll get 3,100. And then you do the same thing for the next one. So you substitute in P as 150. I'm just going to copy down that table, and that will give me these numbers. So you can see that the numbers of crimes, they decrease as the number of police increase. Okay, because no one wants to start trouble when the police are around. All right. Now, once you do that, you can graph this out on a number plane. So you can graph this out on a number plane in your books normally if by using the whole page. And you can go up by maybe 10s here, okay, or 20s here usually, not like this because you've got little grids here, little squares, whereas in your grid books you have larger squares. And then over here you can go up by maybe 200s or 400s maybe, okay. And the bigger your graph, the better. Okay, so once you plot these values and join up together, you get this line, which is a line sloping down. Okay. What is the gradient of the graph you just drew in part C, and what does it represent? So, the gradient you can actually find just by getting y2 minus y1 over x2 minus x1. So we can go ahead and do that, right? So we can get 2,800 minus 3,100 first. I'll just do that right here so you can see it. So m equals to 2,800 minus 3,100 over 150 minus 50. Okay, so if I do that on my calculator now, let's see what I get. I get negative 3. Okay, now what does this actually represent? Well, if I write m equals negative 3, that's the same thing as negative 3 over 1, where this is my rise over run. Okay, now, if you think about it, what does run represent? Run represents x, rise represents y. Okay, but in this case, we've actually got not x and y, we've got p and c. So this means that every single policeman there is increasing, there is a decrease of 3 crimes. Okay, so we can say that as the number of police increase by 1, the number of crimes decrease by 3. Okay? All right. Question 8. What is the vertical intercept of the graph you drew in part C, and what does it represent? Okay, so the vertical intercept here, if we have a look very, very closely. Now, when you graph this on your graph, it will be different, usually. But having a look at this, it's right in between these two numbers. So if we add them together and divide by 2, 3,005 plus 500 is 3,500 plus 3,000 is 6,500, and dividing that by 2 is 3,250. Okay. So what does this represent? This represents the number of crimes at the very beginning, okay, when 0 number of police were patrolling. Okay, so this represents the number of crimes occurring with no police patrolling. Okay, there we go. All right, moving on. Question F. Calculate how many crimes were committed when 100 police officers were on patrol. So we know our formula given in the beginning of the question was this. Oops. So all we have to do is replace P, which is number of policemen, by 100. Okay. And so once we substitute that in, we get C as 2,950. All right. Then we're going to go on to G. Calculate how many police officers are required to reduce the number of crimes to 1,900. So if the number of crimes, which is C, is 1,900, we can replace that in here. So 1,900 is equal to minus 3P plus 3,250. And we can subtract each side by the 3,250 so that the term with P can be almost by itself. And once we do that, we get 1,350. That's negative on the left side. That's equal to 3P, negative 3P. So dividing both sides by 3 now, negative 3 I should say, I will get 450. So that means when the crime rate was 1,900, number of policemen that were around was 450. And that's how you do linear modeling. Hope it helps.